All right, guys, this is a continuation of 9.6 for Calculus BC. And I want to congratulate you because you are done learning all of your series test, okay? So what I want to do is really quick sum it up and show you what this feels like and looks like either on a chapter test or on the AP where they are all mixed together. And how do you know which test to try first, okay? So here are some quick guidelines. Always try to apply the nth term test first. It's a quick and easy foolproof method to check for divergence, okay? Then you want to look for the patterns in those special types of series like geometric, p-series, the telescope, and alternating. Those are the easiest ones to visually catch, okay? Then the next ones that are probably easy to catch is integral, root, and ratio. In an integral, you're going to look for some easy antiderivatives like inverse trig or u sub. In root, you're going to literally look for an n in the exponent, okay? And then for ratio, you're going to look for multiple n's throughout your series, okay? Now, if you've checked and you can spot one of those that they work exactly according to the rules, then that's where you're going to try one of your comparison tests to make them be compared to the geometric or the p-series in specific or alternating, okay? So now I'm going to show you 7 questions, okay? Now, for these 7 questions, this is what it feels like on a test or on an AP. It just says determine if the series converges or diverges, and there is no clue as to which test to use, okay? So I want you to take a moment, pause this video, and with about 20 to 30 minutes, try to solve these 7 on your own. Then come back, press play, and check your work. All right, guys, so if you're not taking my advice and you did not pause this video, or maybe you did and you got stuck, let me give you some hints and encourage you to try again, okay? Just looking through these, if I look at my first one, remember, you're always trying that nth term test first. I see that I do not get, based on horizontal asymptote rules, when I do the limit to infinity, I don't get 0 here. I'm going to get a 1/3. This is an easy one, okay? For the second one, I do see that special case of geometric. Another option here would be the fact that I have the n and the exponent to everything, and you can try the root test. Now here you might think of doing root because you see that n and the exponent, but it's much more complicated than a root. But I do see a nice easy u sub going on here where I'm just missing a -2. So maybe the integral test would help there, okay? Now, for 4, when I try the nth term test, this one is bottom heavy, so it does not work. I would have to try something else. So if I don't see any of my other special types, maybe I can try ignoring this +1, and then I can use one of my comparison tests. Over on number 5, this -1 raised to the n hopefully makes you think of alternating. Here on number 6, the fact that I see an n factorial and an n in the denominator's exponent makes me think of that ratio test. And then for 7, the fact that I have this n as an exponent to the entire fraction makes me think of the root test. All right, guys, again, I encourage you to pause, and now with those hints, try again. All right, guys, let's take a look at the solutions to these. So looking at this first one, we did say to test out the nth term test first. So when you solve the nth term test, the limit to infinity, we have the same exponent. So my answer is my coefficient's 1/3. And since the limit to infinity does not equal 0, we can go straight to divergence. All right. That's a nice, quick, easy test. If we had that this equals 0, we'd have no conclusion and we'd have to try another. Let's take a look at the next. Okay. We said that one option here would be geometric, okay? And another could also be, because there's an n in the exponent, the root test. So let's take a look at both of those, and you'll see that both of those, hopefully you got converges for this one. So by geometric, that r, right, is pi/6, which is a value less than 1. So by geometric, it converges. If you did the root test, you do the nth root, which cancels out that n. You do the limit as n approaches infinity of what's left, and you get pi/6, which is less than 1. So you get converges by either of the rules, okay? More than one method to get to the same answer. Let's take a look at our next one. Okay, when we looked at this one, we said that we saw something that would look like an easy u sub, okay? So we have that negative n squared. We also maybe thought root, but because there's more than just an n going on, we can't do the root test. So this one's a little lengthy, but let's take a look at it, okay? In order to do the integral test, we have to confirm that it is positive and continuous, which is easy to see. This is an e function, which is always continuous, and we see no negative sign. And decreasing, the way I feel like was fastest for this one, I know the e to the x graph, which in this case they're using n, always goes increasing. But if I put a negative in front of that exponent, it changes to decreasing. And then the only additional things in this function here is an n, which would multiply it and make it bigger, and a squared, which would also just make it bigger. So bigger values, but yet still decreasing, okay? Multiple ways you could have checked that out. So then when I go to do the integral, okay, I'm going from 1 to infinity. When I set up my u sub, right, I pick that negative n squared. U prime is negative 2n. I'm missing a negative 2, so I put it in along with the negative 1/2, okay? Remember that when you do u sub with a definite integral, you have to change your u's. So I plugged in infinity and 1 into my u, and I got negative infinity and negative 1, and I replaced my entire integral in terms of u's, okay? I changed the a and the b, and the exponent, and the du for the derivative. Next, because this is a infinite integral, this is another BC concept, I rewrote it in terms of the limit. I replaced that negative infinity with a b. I did my antiderivative, okay? I did my f of b minus f of a. Now, I'm going to replace that b with that negative infinity, so notice from here to here, I do not write the limit anymore. And then at this point, I know that negative exponents take me down to denominators, okay? I know that e to the infinity is just infinity, and a fraction with an infinity in the denominator is bottom heavy, which gives me 0, all right? And then at this point, I would just end up on the inside with a negative 1 over e times a negative 1/2. And because I get an actual numerical value, the integral test says that if the integral converges to an actual number, then the series also converges as well. All right? Looking at number 4, my function is 1 over 3n plus 1. This is a really easy one to do the nth term test real quick. And at some point, hopefully, you'll get to the point where you're doing that part in your head. Okay? So if I know that if I do the limit to infinity, this is bottom heavy, okay, to be 1 over 3 times infinity plus 1, and bottom heavy equals 0, therefore I have no conclusion, okay? So if it would have worked, it would have been a real quick, easy one, but I like to rule that out quickly. So the next thing I'm going to do is I'm going to try the comparison test, because if I can eliminate this plus 1, then this is something a lot easier to work with, okay? So let's look at the comparison test, okay? I'm going to compare it with 1 over 3n. Now, because this has a plus 1 in the denominator, this denominator is bigger, which means this number as a whole is smaller. So if I'm going to be testing the larger one, then I'm testing for convergence, okay? So when I test this one, the larger one, I'm going to pull out that 1 over 3 as a coefficient in the front, and then I'm just working with 1 over n, which I know it's a harmonic, and harmonics always diverge. Because I was testing for convergence and came out with divergence, I have no conclusion. So when comparison test doesn't work, your next best bet is limit comparison test. For a limit comparison test, you have to confirm that both the original and the one you are comparing it to, which we're going to stick to 1 over 3n, are both positive. I don't have any negatives there, so we're good. Next, that the limit to infinity of the original divided by the new one that I'm comparing, okay, that the limit to infinity, when I clean this, I'm going to do keep, change, flip, right? I'm going to get a number between 0 and infinity, okay? Even if I would have used 1 over 3n, this would have come out as 3 over 3, which is 1, which is still a number between 0 and infinity. When it's in between 0 and infinity, I can test either, okay? Step 3 is that if these two are true, then the limit, I'm sorry, not the limit, the answer to the series of the one that I'm comparing will prove convergence or divergence for the original one. So notice that step 3 is exactly what I did on this step, but because step 2 told me I can test for either, that divergence that I got from here will confirm that this indeed is divergence, okay? So I just kind of rewrote, took out the 1/3, said that it was harmonic and that it diverges, okay? So again, because of step 1 and 2, I could test for either convergence or divergence, and therefore we came to the conclusion that the original also diverges, okay? Let's look at our next one, okay? Taking a quick look at this, I automatically see that -1 raised to n, which means that I want to test alternating series first, okay? So alternating series, you have to confirm that it alternates, which I can by that, okay? I want to test that the limit to infinity equals 0. It's bottom heavy, it does. And then step 3, I want to prove that it is decreasing, okay? Because I have that times 4 and plus 1 in my denominator, that means my denominator is going to get bigger and bigger and bigger. And if my denominator is increasing, then my entire number is decreasing, okay? All right. And I showed you an example with a few numbers. And in alternating, if you can prove all 3, you prove that the entire series converges. Number 6, I see that there's an n factorial and an exponent of n in the denominator. So the fact that I see multiple n's makes me think of the ratio test, okay? So ratio test says that the limit as n approaches of infinity of the original with 1 being added to the n's divided by the original, right? So then I do keep, change, flip on the right, and then on the left, remember that n plus 1 factorial can be rewritten as n plus 1 times n factorial. And the denominator, I can split that as 10 raised to n times 10 raised to 1. At that point, I clean out my 10 raised to n's and my n factorials. I rewrite what I'm left with to finish my limit to infinity. I get infinity plus 1/10, which is infinity. Therefore, it diverges. Okay? And for our last one, okay? All right, so the fact that this function has an n in the exponent of the entire function, this makes me think right away of the root test, okay? So, by the root test, seeing that n in the exponent, I set the limit to infinity, the root of n and the n in the exponent cancel, and then here I can use my horizontal asymptote rule. My exponents are equivalent, so I'm going to use the coefficients of 1/2. And because 1/2 is less than 1, then it converges. All right, guys. Hopefully you were able to get the majority of these right on your own. And if not, then you understood them with the explanation.